All right, let's get started for today's lesson. So let's start with our mahia, which is a kind of summary that we're looking at. And I'm going to pick people out of the jar because I haven't done that before for the mahia. And I think that's a good kind of way to make sure you've engaged with that. So while we're looking at this, it's basically a fill in the blank. We have osmosis, which is one of the major themes in this topic. Can I get headphones out of ears? Make sure you're all listening. All right. Osmosis is the movement, and what I'm looking for is two words. Water what? Molecule. All right, from a region of two words. I should be picking out of the jar. All right, two words. A region of. Person answering that question today is Neil. So what am I going to start at? A high concentration. I'm going to write conc as a way to write shorthand for concentration. To a region of two words. Latoy. Low. What? Concentration. All right. The water molecules move across a blank membrane. So, person answering that is going to be Presley. Blank.
Concentration gradient.
So the molecules move across a what type of membrane? Do you remember?
A cell.
Something with a cell, yes, and that cell membrane is semi. Do you know the next word? Permeable.
Permeable membrane.
And I can't spell permeable right. Let me find that word. Semi-permeable. Membrane, because I'm not a good speller. There we go. Permeable is spelled semi-permeable membrane. Osmosis is a special case of, person answering that is Phoenix. Do you remember? Diffusion, yep. Cool? We good? All right. So, like I said, for this practical assessment, there's going to be two things you're going to be thinking about with the scientific ideas. It's going to be osmosis, and the other thing will be on surface area. So, for today's lesson, I'll just move this piece of paper so you can see the learning intention. What I need to do is define the practical that you guys are going to be doing for this internal. So let me move to the Google slide so we can talk about the lesson instructions of how to carry out your practical for this internal. The reason why I need to do it now is so that we have enough time on Monday and you guys can just dive right into it. Then I'll give you guys a little break from me talking and you have a Scipad page just to review osmosis, and then I will talk about the three possible graphs you might get from your data, and then whatever leftover time we have left, I'll let you guys work on those two practice practicals that you had so you guys can still get some feedback. All right. So basically with the success criteria, you're going to be able to plan an experiment and also process the results. All right, so let me kind of give you an overview of what we're thinking about for this practical. So in a moment, I will do a step-by-step instruction on the practical and its method and what you guys need to do. It's really important that you guys listen to these instructions because I will not be able to answer and do any verification questions when you guys do the actual practice assessment. I am, as always, recording my lesson right now, so you can refer to and watch the video that I created for this lesson to help you guys out on Monday, but I can't give you any instructions and directions when it comes to the experiment once you guys start. Does that make sense so far? So it's also really great if you guys ask me questions while we are doing this practical so you can get the clarifications you need. I will also be showing you guys some of the Scipad as well. because pages 48 and 49 have a really good example of an experiment, and that experiment is very similar to the one that we are doing as well, and so you can use that as a reference point to help you guys out. Be mindful that on this internal, you are allowed to look at the previous 2 practicals to help you. You are also allowed to use your notes and your Scipad and everything like that, so that can help you basically write your report and things. So do keep in mind that we are assessing you on your ability to carry out a practical. So that's a skill set. Are we clear with that so far? Mm-hmm. All right, so what I'm going to do is I'm going to shift my computer and I'm going to shift my document camera over that table. You guys will be able to stand around me while I walk through the experiment. Sound good? All right. You might want to take a piece of paper with you to write some notes down. You might want to open up that Scipad to those pages so you can make some notes onto the method, whichever, to help you remember these instructions. All right, cool. So what I want to talk about is the internal practical goal that you guys are going to do on Monday. And I want to walk you guys through the steps. Now, actually, a really good reference to help you guys out when doing this practical is actually this Scipad experiment here. So this is Scipad experiment on observing the effects of tonicity on tissues. And what they've done in their example is they've changed the sugar concentration, and they are soaking bits of potato in these different sugar concentrations and seeing if those potato chips are increasing or decreasing in mass. Are we good so far with that? So it's very similar to what you guys did in that first practice practical with the dialysis bags, and how you were putting a sugar solution bag into a water container and a water tube into a sugar solution. So very similar to that. So when we're looking at these sort of instructions, the first thing to kind of keep in mind is we aren't using potatoes. Instead, we are using turnips. These are massive turnips. It basically looks like a baby, doesn't it? It feels like a baby. It's quite heavy. All right. Each group, I might just switch back to camera. Each group is going to get their own turnip. And from this turnip, you need to get 20 pieces that are the same size. Because remember, the size of these little turnip pieces that you make is going to be a control variable, because we need to make sure that you have the same surface area to volume ratio. Are we okay with that so far? So each pair will get one of these turnips. What you're going to do is you are going to cut these turnips at about the 7 centimeter mark. You can probably get a couple out of there. You probably can cut this into thirds, and that should be good. I'm just going to probably roughly cut it here, so I want to make sure I have enough kind of space. So that's just an end bit, so I'll take that guy off to make it easy. And then I might do a little bit longer. There we go. About there. There we go. It's actually quite easy to cut. All right, so that is our turnip. You're obviously going to take quite a few cuts out of that because you're going to need to core the turnip. So we need to prepare our little cylinders of turnip for this experiment. So what you're going to be doing in this experiment is you're going to be testing 5 different concentrations, okay? The first concentration that you are testing is 0 moles per liter of salt, so basically no salts, and that's going to act as your control. You then have to do 4 more concentrations. Can we be off the phones, thanks? You're going to do 4 more concentrations. You can choose what concentrations you want to do. I believe we're providing you 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8 as your choices. You obviously don't need to do all of them. You need to choose 4 so that way you have a nice good range. Are we okay with that so far? Yep. Right, and you are going to repeat this experiment 4 times. So you're going to have 4 samples to measure to make sure that they are correct. So if I have 5 different concentrations and I'm doing 4 repeats, I need a total of 20 turnip cores. You see how I did that math? 20. 5 different concentrations, 4 repeats. 4 times 5, 20. Are we good? All right. And we want them to be all the same size, so that way they have the same volume, they have the same mass, we can control, same surface area, so we can control for that. All right. There are 2 different cores that we have. These are 7-inch or so cores. Now, obviously, we're not going to use this cores straight from the 7 size because we want to make sure we adjust them so that way they're all the same size. So 2 different options. You have this one here that you would shove into your turnip. Now, this first one that I just shoved isn't really a good example because you see how I've gotten through the side. So I probably wouldn't want to use that one as my core. So we can discard it. It's going to take you a while to kind of get some of them going. And then you have the little wooden hole to get it out. So I'm going to try that again, get a better one out for you. There you go. That's much nicer. There we go. And that's going to be my first little tube. Isn't that cool? Nice little size one. All right. I will only set up an example at 1 concentration, and that 1 concentration is going to be at 0. And then obviously, once you get all your 0 ones completed, then you move on to your second concentration. You want to start from the lowest concentration, working your way up. Okay? So, I need to have 3 more. So I can use this guy. If you have this core, which is just the metal tube, you're going to need to add a cork, so that way you can push it and not hurt your hand. So there's a little one with the cork as well. Works the same way. Shove it in, pull it out, get the little rod, and get it out. So be mindful that you want to use the same core throughout your experiment, so that way you have consistent cores. Again, another kind of thing that you can control for. Are we good so far? All right, I personally like these ones better, so I'm going to use this one, and I'm going to get 2 more out. There you go. Number 2. You're going to get 20 of them. You have a whole turnip to get 20 of them out. And obviously you got to use the same turnip because the turnips could vary based on their cellular makeup and quality of the cell. Does that make sense?
Are they all going to be that big?
Yeah.
Shit.
Yeah, you're going to have babies. Turnip babies. All right. Are we good with that so far? All right, so I got my 4 pieces ready for my first kind of setup. I want you guys to obviously get all of your turnip cores done first, so that way they're all pre-ready to go, so you can put them in your tubes and put them all in at the same time. All right, I think this one actually isn't a good one, because looking at that, I can see that there's a little bit of a hole there, and that's going to increase my surface area, and also I'm going to lose some volume of turnip. So I can discard that one and go, you know what, I'll do 1 more just to be on the safe side, because you want to have good quality results. Cool. All right. Now, once I have my turnip rolls ready, the next thing I need to do is measure them out to be 6 centimeters in length. So I made them a little longer than 6, so that way I can keep them nice. I can have a little bit of space to chop off. I also want to be mindful that the ends might not be perfectly nice and smooth, so I might do a little bit of a chop just to kind of smooth it out. And that's my clear end there. Take my ruler and measure it out to be 6 centimeters in length. So again, we're trying to make sure that we are controlling our variables In this case, the variables that we are trying to control for is our volume and our surface area. So we want to keep those the same because what I am changing is the concentration of the solutions that I put them into. So I'm just cleaning off the edge.
Will we just be working in pairs?
You will be working in pairs, and so you'll be able to divide up the work. So when one person is pouring the turnip, I suggest the other person prepares the vials. Are we okay so far?
Yes, ma'am.
All right. So that's the first thing you need to then do. The second thing we need to do is we need to soak these turnips. Now we need to know how much solution to put inside them. So you're going to get a vial, and you're going to get a vial for each one of these turnips. Okay? So what I need to be mindful of is I need enough solution to cover the turnip. Now I'm only putting one in there because I don't want to overcrowd them. I want to make sure they all have access to the water. So what we're going to do actually first is we are going to put some water into the vial just to get an idea of what amount I need. So I just want it enough to cover the turnip, like that. That should be good. And then what I want to do to make sure I know what the volume of water I'm putting into each one of my little flasks is I'm going to pour it out. I'm going to take out my little turnip, and then I'm going to measure this amount of water. So I get a measuring cylinder. I check with the bottom of the meniscus. And for me, I found that it was 21 milliliters covered my turnip. Okay? So I would make a note of that in my method that I'm using 21 milliliters of solution for all of my glass vials. So what I would then do, now that we know that, one person in your group cuts up the turnips, get them ready. Other person in your group preps the vials so that way those are ready for the turnips to be dropped in. Because we want to put the turnips in all at the same time. If I put them in at different times, they have different soaking times. The other thing to keep in mind is that you should be labeling your vials. So we have little permanent markers. With the labeling, you put the concentration of the salt solution and the number of what sample it is. So you have 4 samples. Or sorry, 4 repeats, I should say. So, in this case, we have the 0 mole. So I'm just writing 0 m, moles per liter of salt water. And this is going to be sample number 1. Cool. So I'm getting all 4 vials ready. Obviously, you're going to have 20 when you guys do this because you are doing your different concentrations. I'm just showing you basic setup. This is my second one. This is my third one. Number 3, and then this is my 4th one. Cool. All right, now that I know that, what I'm going to then do is I want to fill up each one of those vials. Now to make sure I have enough, I had roughly 20, right? So 20 times 4, how much do I need of water?
20. Oh, wait, what is it?
20 times 4, how much do I need? I need about 80 mils of solution. So what I'm going to do is when I go to the bottle to get my 0 molar solution, I'm just going to go and I'm going to take my beaker and fill it up to about 80. I'm going to do a little bit more because I know I had 21. Okay? I have 2 different size beakers, so if you feel like you want to use a larger one, you can, or you can use a smaller one to collect your concentration of solution. Start with the lowest one, working your way up. Because the reason why is if I start at a high concentration and then I move down to the lower one, I might have some extra leftover salt, and that's going to influence the concentration of the one that's lower. In this case, if I'm starting with water, there's no salt in there, so the next one that I go up won't be affected. Cool? All right. So then what I do is I measure 21 mils for each one of my little cylinders, get those guys prepped up. If you want to be a little bit more accurate, we're going to give you guys these little pipettes so you can remove solution or drop solution in there. Cool? So because I'm just demoing it quickly, I'm just going to quickly drop everything in there. Cool. All right, that's everybody sorted? All right. Now, before I just drop my turnips in there, I need to know what their initial mass was. So what you need to then do is get a paper towel, because we want to dry off the turnips. We don't want to just drop the turnips into the water. We don't want to drop them onto the scale without making sure they're dried off first. I want to remove any excess water, because that excess water could influence the weight. Now, it's up to you guys how you want to do it. Some of you guys just might pat them dry, but if you want to be more accurate and precise with your data, you'd be like, I'm going to roll it 3 times, and that's going to ensure that it's dry. Or you can say, I roll it 5 times. And you do that with all of your turnips before you weigh them, so that way you know that they're dried off. Does that make sense? All right, then what I need to do is I need to weigh them. Use the same scale, because again, if there's any error, it will carry over. With the scale, make sure you are folding the paper into twice, so that way you have a little bit thicker. You're going to put it on the scale, and you're going to make sure it zeros, so that way you can then take the measurement of the initial.
Can I go to the bathroom?
Yeah. Make sure the units on the scale is in grams and not in ounces. So, put the first one down. Make sure you are writing down your samples. So, for example, you can write them on the paper towel that you're using. You can get a piece of paper to write it down. I'm writing down that this is 0 m at sample 1. Two, 3, 4. Other thing I want to do is initial and final. Because I want to take the initial mass on the first day, and then we're going to see it on the next day and see how it changes. Are we okay with that so far?
Yes.
So I go through, I weigh it, and I go, okay, this one's 6.11 grams. All right, that one's number 1. I'm going to make sure I don't confuse them. Here's number 2. Put it down. This one is 5.72. Okay, move on. Keep them in the right order. Next one, 5.44. Take it out. Next one, 5.44 as well. Oh, that's pretty cool. All right, so now that I have all these weighed and ready to go, once I have all my turnips good to go, I'm going to put them into the vials, and I'm going to put them into the vials all at the same time. So one person in your team should be sorting out the turnips, cutting them, weighing them. The other person in the team should be sorting out the vials. Okay? Once you are ready, Tupo, the mask. If you need a mask, there's some over there. All right. So then you guys will put them all in at the same time, so that way they have the same soaking time. Like that. And you'll do all the samples, so all the different concentrations. All right? Are we good so far? Okay. Now what I need to do, once I have all my samples ready, this is going to be an overnight experiment. So you're going to put all of your samples into a container like this. Now this container is bigger than the number of samples that you have in here. So be very careful when you put things in, because you don't want any of the vials to fall over and lose solution. What we suggest you do if you have extra space is you take a piece of paper or take a piece of tissue paper, crinkle it up, and put it inside the box so that way it doesn't shift and move around. Are we good so far? All right, then I'm just going to grab another piece of recycled paper. you're going to write your names on a piece of paper. So I'm going to write Ms. Garlic. And you should have 20 samples in your box. And you are going to take some cling film and you're going to cover it. Now, why do you think I need that cling film? To cover it. So no air gets in. What do I not want to happen to that water?
To evaporate.
I don't want it to evaporate. I want it to stay here. So that's going to be another factor. So you're going to put some saran wrap or some cling film on it. And what you're going to do is we're going to have a trolley and you're going to give it to me. And we are going to put it into an incubator. So you're going to put it in an incubator that should be roughly 25 degrees Celsius. So that way it's all at the same temperature. All right? Another thing to keep in mind and control for. Once that is done, we'll leave them overnight. Okay? So you pretend to walk away. I'll confirm what the temperature of the incubator is. You come out, you grab these the next day. Okay? So that'll be on Tuesday, because I think I see you Monday and then Tuesday. All right. So you take them out. You're going to take out your turnips. All you need to do, because we're not worried about keeping any of the solution, is pour the solution out so you can grab your turnip. It's just going to be salt water, so it's not going to hurt you. Again, before you weigh it, you need to dry it off because I don't want to weigh any of the mass of the water that's on the outside. I just want to measure the mass of the turnip. So we're going to, roll it again, keep it the same how many times you roll it, and measure the new mass. So again, keep your paper from the last day, and then since that's sample number 1, we can then write again. Let's say it's gained and it's now like 7.51. All right? Are we good with that so far? So you're going to do that for all of your turnips. I'm trying to think if there's anything else I need to tell you guys when it comes to this. I think I've covered most of it. And obviously you're going to have to calculate the difference in the mass and then the percentage mass change. All right? What questions do you guys have about this? Nothing? All right. If you guys want to you should be doing 4 repeats, so that way you have an average. So every single turnip that you make, you should be weighing. If you want to take extra observations, you are more than welcome to. So you can make observations on how stiff your turnip tube is, or if it's really kind of soft and squishy. The other thing if you want to do is you can take measurements to see if the length of the tube has changed. Has it gotten bigger? But if you are taking those extra measurements, only do it for 1 turnip in the sample size. So like 1 at each, like 0, 0.1, 0.3, that sort of thing. You don't need to do it for all 20 turnips, okay? It's just if you want some extra data to write up for. And then when it comes to cleanup, turnips can go back into the rubbish bin. We're gonna throw those all away. Everything needs to be washed and wiped down, especially these vials. Make sure those are cleaned out. I'll give you guys some methylated spirits so you can wipe off the Sharpie. And I think that's more or less it. Obviously washing these guys off and putting them away so that way we can dry them in a dryer. Cool. I think that's everything I need to cover for this. Right? I'm going to give you guys a little break to do some work on the osmosis page, and then I will recap what to expect when it comes to the different graphs that could happen when you get your data. All right? Keep in mind that I cannot answer any questions on this, on the method of this practical on Monday. You guys have listened to this. If you need to have additional information and reference, you can watch this video that I've made. But I can't answer or give you any more instructions after that, once we start Monday. So if there's any other questions right now that you want me to clarify.
So you're not going to explain this on Monday?
I can't explain it again on Monday. You guys have to watch the video again. Okay?
On Monday?
On Monday. So I'll upload this video. You can watch this video again if you need help trying to figure out the method, but I can't give you any instructions because you guys got to carry it out yourself. You also need to write your own method. So when it comes to writing your own method, you can watch this video to understand what you might have done. There's also that Scipad page, like I said. This one is also really good. It's similar to what you were doing. They just changed from salt to sugar, and they're using potatoes instead of turnips. But it's very similar as an idea of the experiment. All right. Any final questions? Okay. So I want you guys to do the Scipad page on osmosis. And then I'll talk about what to do with the graph. So let me stop the recording. So since I'm not sure, can everybody listen up?
It's hot. Is there like a heat on?
There's a heater right there. You're sitting directly under it.
This?
Yeah. All right. Can everyone listen up? Because I'm mindful that when we start the assessment on Monday, I can't answer questions that are in context for the internal. I can answer and give feedback on the other two practice ones. So if you want to kind of keep working on those, even when we start the internal and you want feedback, I can give you feedback on those things, but I can't give you feedback on the actual internal while you guys are doing it. So that's why I want to talk about these sort of things now. So you have this as information and you can refer to these as your notes because you are allowed to use your notes on this internal. So I'm also mindful, I don't know when the bell's going to go for the ball tickets. All right. So there are 3 possible graphs that you might get from your data, and I want to make sure you know how to state what's happening with each one so you don't accidentally get it wrong and thus prevent yourself from getting the higher marks. So let me show you guys on the document camera the 3 different options. So there are 2 that are most common, and I'll point those ones out first, and then I will point out the third. Actually, no, I'll just start with the most common one, and we'll move on. All right. So out of these graphs, 3 things are likely to happen. So you're going to graph your data. You're going to notice on the x-axis that this is going to be your salt concentration. Yep. Can't see it because it's not duplicating. Let me fix that. Thank you. All right, so on the x-axis, we're going to have our salt concentration, which is what you're going to be changing. And the units for this is going to be moles. Moles is referring to a concentration unit, which is moles per liter. So basically, how many particles do you have in 1 liter? Remember, like I said, that is what we are changing in this experiment. The thing that you are measuring then is your percent mass change. So we're going to see how the percent mass change, and on the y-axis goes your independent variable. I want you to both do a data table and a graph, so if you make a mistake on one, I can still pass you on it. So you get 2 chances for it. The other thing to keep in mind is make sure you have details in your data table. Make sure your data table is nice and neat and you're wrapping your text so that way I can read it. So that's why I'm being specific. Salt concentration and the unit, percent mass change. Be mindful that at this point here is our 0. So in some cases, the mass might increase. In other instances, the mass might decrease. Okay? So I'm just doing a general graph that you might have potentially on this assessment that looks like that. Now, looking at it, what do you guys think the trend is? As I increase the salt concentration, what happens? The percent mass decreases. We need to be really careful with how we describe things. So I want you guys to be mindful that this here is the isotonic point. And I need you guys to identify it. I hear music being played, and I want that to stop. Is it from outside? Oh, it seems to have stopped. All right. Do you guys remember what the isotonic point is? It's when the concentration inside the cell and outside the cell are equal. The concentration is equal to each other. So the water going in and the water going out is going at the same rate. Are we okay with that so far? Can we put away the phones? Mitchell, the phone. All right. What I want you guys to notice with this trend is that before the isotonic point, we notice an increase in mass. And after the isotonic point, there is a decrease in mass. Oh, sorry, I wrote the wrong word here. That should be increase. There's an increase in mass before the isotonic point. After the isotonic point, there is a decrease in mass. So I just want you guys to be careful when you're stating your trend that you are looking at it carefully and not just stating the trend of the line, because I don't want you just to say the mass decreased, because the mass decrease is not the correct trend. The mass decreased in some cases, it didn't decrease in all cases. Does that make sense? So be careful. When you look at this line, you might go, oh, decreasing, and that's all you think about. But you have to be specific and go, before the isotonic point is actually showing some increase in mass. After the isotonic point, that's where we start seeing the decrease in mass. Are we okay with that so far? Any questions? All right. So just kind of keep that in mind. Don't just say the mass decreases. And I'll write that down because it's, or do you not want me to write that down? Do you want me to write that down? Don't say mass decreases. So you remember? For this graph, don't just say mass decreases. I should say type of graph. Say mass decreases as your trend. And that's because in some cases it would increase, in some cases it decreases. Mm-hmm. Yes, I'm recording it and I'll scan it as well. That's after the ISO point. Cool? Are we good? Yeah.
Why is it
So in this case here, before the isotonic point, it's going to increase in mass. So if I was to draw my little cell in the water solution, so water, that's my cell. What has happened in this case is that the water has moved into the cell. And the reason why is because this here is a hypotonic. So it has a low concentration of cell lutes, whereas this one is hypertonic, which has a high concentration of solutes. So remember, with the osmosis, the osmosis is going to go down the concentration gradient. So this has a high concentration of water, so it's going to go into the cell, which has a lower concentration of water. Does that make sense, Juliet?
Yeah.
Okay. All right, when I get to the isotonic point, there's the equal concentration of the salt, so it's going to move in and out at the same rate, so there's going to be no change, and then afterwards, I'm going to get the reverse happening, and the water is going to go out of the cell. If you're not sure about this, you should be doing the Scipad pages on tonicity and on osmosis. books, which I'm not sure off the top of my head what pages they are. I think I have 44 and 45, but that's an old version of the book. What you're looking for is this page in the Scipad and this page in the Scipad. Okay? Cool. All right, all senior students going to the ball. I'm not sure if you guys are going to come back. I can finish these graphs on our next chance that we get.